not recording. So let's start over. Here we go. Okay, good. So those of you watching the videos, huge apologies. I talked for about 2 minutes before I remembered to turn this thing on. What I said was I'm going to give you a list of 4 or 5 thoughts you should go through before you start a problem at the end of chapter 10, maybe sooner. And this is the first of those questions you should ask yourself. What parameter is the question dealing with? There's only 2 options in our course because we only covered these 2 parameters in terms of confidence intervals, etc. And that's the mean or the proportion. And we just discovered that this is about a mean because it literally says mean. Those words are there. It's not always that obvious, but sometimes it is. Okay. The second question you should ask yourself is, what is the question? What are you being asked to do? So let's look at number A. If the researcher wants to construct a confidence interval, which formula will she need to use to determine the minimum sample size? All right, so we're being asked to find a sample size, and we're only being asked to state the formula. Okay, can you all do that? Nice. All right, so now that we know what we're doing, let's do number 1, A through E. Ooh, this is gonna be fun. Yeah, let's see how you do. So I'm gonna give you 5 minutes. I got 1 thumbs up for which formula. If you didn't know which formula, let me talk you through how to find that. You go to page 274. The reason I suggest you work with page 274 is this is the provided reference sheet for you. You can also handwrite these on your own reference sheet and organize them how you want. Maybe you like it better that way. It's up to you. And we come to this sheet. This is the how many question that you're being asked to figure out. Oh, this is for a proportion. This is for a mean. Oops, I highlighted the wrong thing. Here's the word proportion. Here's the parameter symbol. Here's the parameter symbol. So we know this is the formula we're working with. So the answer to A is just copy this down. Okay, so let me turn you loose for 5 minutes to see if you can't finish question 1. See if you can't get all of them. It may take you more than 5 minutes, but we'll probably answer. See if you can't definitely get A, B, and C done. Set a timer, 5 minutes.
Excuse me, Eric. My kids are all home today, so I have a whole motley crew. I just got situated. I didn't hear what you said we were doing. I see the paper that you have out. So what are your expectations right now?
So you are on the clock. So you better get caught up. You got 3 minutes and 43 seconds left to answer number 1. Just kidding. I'm glad you're situated and that you have your children with you. That's going to be fun. So you're just seeing if you can't get through this.
Okay.
What we've noticed is this is a mean, and we answered A. That is right. This is the formula. Is all of Jackson closed for some reason?
Yes, and my kids are screaming in the other room about how one's laying on the bed diagonally. Oh my God, like I can't.
What has happened is all of the Jackson ISD and all of the Hillsdale ISD, supposedly there was a cyber attack. And they attacked Yeah, so all of the Jackson schools, all of the like Jonesville, Hillsdale, they're all like, they have no power, they have no heat. They got into their thing and shut down all their systems. So yeah.
Wow,
Yeah, so it was like a major thing.
that's crazy. Wow.
Yeah, so they're working on that.
They probably just want 100,000 Bitcoin or something.
Yeah, exactly. So Laura, hopefully they get that fixed for tomorrow.
All right. Yeah, but I'm not worried about them being home. I was hoping that the college was going to be closed.
Well, if it's closed, we are still like online, unfortunately, going to be open.
Yeah, yeah.
But
All right.
maybe your A&P would be closed.
Yeah, maybe. I don't know. I messaged my.
Yeah, it didn't hit the college.
Oh, okay, good. All right.
Oh, nice. You know, I wouldn't have minded either.
Yes, someone on my level. I love it.
You know, like, I mean, you know. Should I reset the timer for another 5 minutes?
Yes,
please.
Yeah, let's do that.
I'm a little stuck on B.
So, good question. Comes from the formula. In the formula, what is the critical value? Circle it. That thing. Does that help?
Yeah, were we supposed to, so when I go to, I'm supposed to go do it through StatCrunch, right?
You got it.
And, stat calc normal. Am I supposed to hit the between? And then
Good.
put 0.95, right?
Oh, Taylor, yes, money. Good, yeah. You're doing exactly this, and you've just described it, and that gets your Z critical value. Excellent. Okay, let's go through what we got. So one of the things to note here is what this particular worksheet is doing is it's breaking down a big problem into its different parts. So you're going to be handed a problem like this, and you're going to find A, B, C, and D, but you're going to do it all at once instead of it being saying first figure out what's the formula. So I'll just write this down for starters. Oops, there, that was our formula. And this finds the smallest sample size possible. And then Taylor already helped us with this one. We're figuring out what's the critical value. This is Z alpha by 2. Z alpha divided by 2. We probably know this one. It's probably memorized by this point, or you might think about memorizing it at some point because you see it so often. It's the 1.960, I think. Let's see if I'm right. Maybe you all know that. And you don't actually have to memorize it. You go to calculators and normal. Remember, z-scores have a mean of 0 and a standard deviation of 1. And we're using the between for, I did have memorized. Yay for me. Between with the confidence level to get us 1.96. Just in case you needed this, 1 minus that confidence level as a decimal is equal to the alpha, right? So alpha is actually 0.05. You did not need to write that down, but it's important to keep using that. Great question. I think I'm using it because I need this confidence level, this 95% confidence level, to get the critical value. Does that make sense? No good, no worries, you're good. It is, by the way, one of the most common mistakes when I see students working with the sample size formula is they don't put in the critical value, they put in the C level here or some other crazy thing for Z, and you get answers that don't make sense. Okay. What did anyone get C?
I think I got the formula, not the answer though.
So let's see, what did you have for, in other words, you're saying you were able to figure out S. We already know Z alpha divided by 2 and E. You know what those numbers are.
Yeah.
Okay, what's your S?
7.
Good. Does everyone know how we found that S?
The standard deviation is 7.
Right here, we're told this is the standard deviation. Now it says the population standard deviation, and this S stands for sample standard deviation. It's okay to use the population standard deviation in place of the sample standard deviation. In fact, if we know it, we would always use the population standard deviation. We often don't know it, so we use the sample. Excellent. We already know Z, 1.9, blah, blah, blah. How did we get E? Or who knows what E is?
1.5.
Nailed it. 1.5 pounds that was given to us. We're always going to tell you margin of error, and that's going to be your E. If you think back to the confidence interval, I kept labeling it incorrectly. I called it MOE. Remember, you get your point estimate. I called it PE. You got your upper limit. You got your lower limit. Come on, computer. Pull yourself together. All right. So the margin of error, the thing we're talking about is this distance in between the point estimate and the limits. So that's what this number is. Okay. So those are the values. If we're going to do the substitution, we would write it like this. This one, I'm definitely going to require you to write out the substitution because StatCrunch does not have a nice way to, there's not like a menu thing where you get the answer. You're going to have to type this in your calculator exactly how you see it. So that's what I write. And then for me, I prefer Desmos.
I thought the 7 went on top.
Yep. It did. I don't know why I have 1.5 twice. Thank you. Good catch. There it is. Okay, so in Desmos, we can create a fraction just by hitting the division symbol. And that might be kind of helpful because then we can type this thing in exactly how we see it. I'm going to put parentheses around it, and then the squared thing, you can just use this a squared, and there you have it. Okay, this one, if you look at what the notes say, it says round up. Well, in this case, if we just followed standard rounding, 83.66 does round to 84. But even if this was 83.10 or 02, we would still add 1 to it. And so you're always adding 1 to your result, no matter what the decimal is. So this is the units on this is adults. Is that what y'all had?
Yes, that's what I had. I was confused when you started right in the approximately 83.66 because I wrote down 83.6 and then I just put equals 84.
Nice.
So
Nice. Good.
I need to write adults on there as well, the unit.
It's a good idea. It's just
Okay.
tracking who are we talking to? Who's in the sample? And sometimes it's like salaries or states or fish or whatever. So it may not actually be people. Okay, so then you get D and E are these little questions that ask you to think carefully about this formula. Like what happens if we mess with stuff in this formula? So the first one says, if we want a higher confidence level, so if we go from 95 to say 97, how does that affect the formula? Well, if you think about the graph here, if we went from a 95 confidence level to say a 99, look at what happens to the amount of area and look at the number here. See how that got bigger? Instead of 1.96 here, it's now 2.575. So if we then go to Desmos and we kept everything else the same and we put in that 2.5758, I'm going to type that in, 2.5758. Look at what happened to the sample size. We now need 144 adults to get to have the same margin of error with the same standard deviation. This happens always. If we make the confidence level higher, it makes the critical values get further away from 0, which makes them bigger. And when you multiply a numerator by a bigger number, the fraction becomes larger. So I just did what we were supposed to do. What happens to the required sample size? It increases. Now, I think you have in your notes some things like if the sea level goes up, then N goes up, right? And that's totally acceptable too, but I'm just wanting to show you numerically why that happens. How do y'all feel about that?
Good.
Okay, what would you answer for E then?
I didn't get that far.
I
Okay.
still have E.
What'd you say?
No, I still have to do E. I made it through D.
Okay, let me give y'all 2 minutes to mess with that.
All right.
Set a timer for 2 minutes. All right, y'all, what happened?
I got
What,
a higher score.
yeah. So what, if we change this to 0.5? Ooh, man, it gets crazy big. Change it to 2. Well, I got some number. 1.1. Yeah. If you think about why, if you divide by a smaller number, the fraction itself gets larger. So if we decrease the margin of error, bring that down, that is going to increase the sample size. Okay. What are your thoughts? Why is it we always round up when we calculate E? By the way, this is that time, remember when I remember how I used to be super picky about people that said, oh, we round up, we round 83.6 up. And I said, no, don't say round up, you're just rounding it. That's the correct method for rounding. And I mentioned that there would come a time when we would say rounding up, and it literally means add 1. And this is that time. But what do y'all think? Why is it we always round up with these sample sizes, regardless of the fraction at the end?
I'm not sure if this is right or not, but you can't have 100 or 83.6 adults. You have to have a whole adult.
Good point. Yes, that's why we always have to round. But what might be the reason that we always add 1? And let me suggest what we're doing here. Let me remind you. Let's see what you said. People being surveyed. I agree. So yeah, that's why we have to have a whole number. But why wouldn't we just say 83? If this had been like
Because
80,
if you round down, then there wouldn't be enough.
that's it. We are demanding, we are getting the smallest amount of people to talk to that meet this critical Z value, meaning this confidence level and this margin of error. If we round down, we won't meet those criteria. If we added like 50 people to this, yeah, we'd still meet it. We'd be far above the minimum, but we would still meet it. So we have to add 1 to ensure that this 95% and this margin of error are met. That's why we always add 1. So your answer here, to make sure we meet the desired margin of error and confidence level. Okay. Number 3. Or let me give you a second to write. I could relax, couldn't I? I could try. Okay, I'm going to pretend like I gave you enough time. So, question 3. First thing we got to figure out, what parameter are we working with? Anyone know?
Proportion,
What? How did you know?
because it says that. Know what proportion?
There it is. Yep, right in the first sentence. This is the one that can sometimes get a little confusing, because sometimes we don't say the word proportion, but this time it was stated. Excellent. Okay, so I'm going to let you do the rest now. I'm going to give you 5 minutes to work through A and B. This is the not broken down into its part question like you did here. It's now just going to be, hey, how many? It's going to be question C. So you're going to have to do these other things. Figure out what formula do you need to use, what's the critical value, etc. So 5 minutes. Let me see if you can do it. I will change my 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 thing back to, here's the formula sheets. So one of these three formulas is the correct one. If you can't figure out which one, shout at us so we can make sure you can keep going.
It's not the same one that we just used, right? Because there's not a mean or a standard deviation or anything.
Good. It's one of the two proportions. It's one of
Prior
these.
And-
estimate? Cause the
Do we
percent,
have a prior estimate?
He's trying to figure out, no, like he's trying to figure out.
Right. In A, I don't see a prior estimate. How about in B? Is there a prior estimate?
Yeah,
What is it?
previous year, 38%
Good.
freshman.
So B.
So for the
uses
first one, we're
annoying
using the n equals point, okay.
Yeah, the nicer.
Oy.
Enjoy, yes. Set a timer, 5 minutes.
I have a question so B, is 38 gonna be 0.38 or 0.038?
So those are the exact same thing. Whether you say
Okay.
0.38 or 0.38, it's the same thing. But yes, you've got to convert it to that percent, that decimal. So that's good.
Okay.
So it sounds like you, oops, sounds like you all are getting it. Let's see. Let's just check our results then. Did you all get it? You had 1.645 as your Z alpha for both?
Yeah.
Excellent. 1.645. The one thing that could mess you up, let's see. I'll just type in my answer and let's see how you all did. So you take that 1.645 and you divide it by the margin of error, but did you convert that margin of error to its decimal and get 271?
Yeah.
Excellent. And then for B, we're just changing that to be the 0.38 times 1 minus 0.38, which is 0.62. Did you get 256 as the final answer?
Yes.
Good, y'all. Excellent. Anyone have any questions on that? I mean, you've done the 3 problems now. Like, we can call it a day.
I was still finishing up the V. I'm pretty slow at these. I have to
Okay.
read over and over and over again to
No worries. You do that.
understand.
Are you stuck on anything or you just needed some more time?
On A, I believe I did it right. And then you put down the 0.25, and I'm not sure where you got that 0.25 from.
Where do you see a 0.25?
In the formula.
In the formula. Right.
Oh, yeah, it's literally in the formula.
Oh, with no prior estimate. Okay.
That's it. That's it.
That's where I messed up. All right.
Yes. So for B, you got to round up to 270, 256. And for A, you also round up for 271, even though that's also the same answer as if you rounded. But you're rounding up on both of them. You're always just adding 1 to whatever you get from the formula. That's just always going to be the case. Excellent. Okay. Again, I don't want to rush anyone. So,
I'm good. Go ahead.
okay, cool. Thank you, Laura, for that. So 4 is an interesting question. We're supposed to put these in order from narrowest to widest intervals. And if you think just conceptually, the wider your interval, the more confident you can be that your answer is in there. The more narrow your interval is, the less confident you can be that your answer is in there.
So it would be 65, 75, 85, 95.
That makes sense. So the narrowest would be the 65 because we are the least confident. So like they could be the closest together. And then the widest would be the 95% because we have the most possible options within there. If that's the only thing we looked at, if we kept the sample size, the proportion, or the mean the same for each interval, that would be it. Good. So 65, 75. Yeah, excellent. Okay, if a sample mean is 100, could the following be a confidence interval for the mean? Interesting. Remind me, where is the X bar or the point estimate within a confidence interval? Where is it at? Relative to the upper and lower limits. Let me see, if I go up here, there's a picture. Where is this point estimate relative to the lower limit and the upper limit?
It's like the mean, it's right in the middle.
Is exactly the middle. Excellent. So I'll give you some time, like 2 minutes, and you figure out, is 100 in the middle of this? In case you're forgetting, one little formula you can use is the upper limit plus the lower limit divided by 2. That's going to get you your point estimate. In other words, see if that's the center of each of those. Set a timer, 4 minutes.
So do we need to do something else for 4? Do we need to find the things in the parentheses, the interval? Or do we just
Nope.
keep it like that?
You just
4.
need to see in, for no, you just 65, 75, 80. You just put in,
Okay, gotcha.
you don't even need the intervals. I was just pictorially drawing. Yeah, pictures and drawings are the same, aren't they? Okay. Okay, how'd y'all do?
I got all of 5 done.
So is the first one yes or no?
No, because the mean is 90.
Nice. How about the second one?
Yes.
Right, because 85 plus 115 is 200 divided by 2, you get 100. Excellent. And the last one, same thing, no, right?
Yep, the mean is 95 on that one.
Excellent. Okay, good. So that's just a quick reminder that if you know the upper and lower limits, you can find the point estimate. Whether this was a mean or proportion wouldn't have mattered. However, it couldn't be proportions because these aren't, unless those were percentages. Even then, no, it couldn't because you can't have a number over 100 for proportion.
Okay,
Okay.
for some reason I'm getting different answers. I put 100 plus 110, or I'm sorry, 80 plus 110 in parentheses and then divide by 2 in Desmos, and I'm getting, it said 95.
It is 95.
Yeah, 95, 100, 95.
95. So 100 fits in.
So it's not, is it within there? It's, is it the exact center? So when you do that sum and divide by 2, you got to get 100, or this is not an interval for X bar.
Oh, okay, that makes so much more sense. Got it.
Nice.
I
Good.
didn't read the instructions, I guess.
No worries, no worries. It's kind of a weird little question. We're just asking you to remember where the point estimate is within the interval. So what did you all say for number 6? Anyone think that's true or false? And why?
I'm just confused by the part where it says over and over again. Like, I feel like that's what kind of makes this not. I said false because I just didn't feel like if you do take samples over and over again.
So not bad thinking. It's a great question of like, why would we do that, right? Why would we keep doing it? The reason we're saying that is because we're talking theoretically. If we continued to take samples from a population of the same size, and we kept making 95% confidence intervals, how many of those intervals should contain the sample proportion? Now, this is the key word here. When we constructed the confidence intervals, we needed the number of successes and we needed the sample size, remember, in StatCrunch? And from that, we built the confidence interval, and each of those confidence intervals had the p-hat where in them. Like, where's the sample statistic in a confidence interval? Where is it located? If you need a hint, look at what you did in number 5 and think about what was it you were calculating? What were you finding back in number 5?
So we're finding the point estimate
And where is it?
So-
Every single time.
in the middle.
In the middle. So this is saying
And
90
p-hat and point estimate are equal to each other.
Right, remember point estimate is the general term for a statistic. And p hat is a special type of point estimate. It's the point estimate for a population proportion. So we're going to generate a sample, we're going to calculate a p hat, and it's going to be in the center of the interval. So what percent of our confidence intervals generated from our samples will have p hats in the center of them?
All of them.
All of them. This is
So
all.
it's false because it would be 100%.
Yep. We are making them that way. Like we're constructing it that way. Now, we could change one little word here and it would make it correct. We would, if we change the word from sample to population, that would be correct. Because that's what the theory says. If we have a 95% confidence level and we keep taking samples over and over and over, 95% of those intervals will contain the population parameter. We don't know where in the interval that parameter is going to be, or that population proportion. It's going to be somewhere. Okay, so 100% will contain the p hat. Excellent. How about B? If you go through life making 96% confidence intervals for all sorts of population parameters, about 4% of the time, the intervals won't cover the respective population parameter. That's true. That's what we were just talking about. 96% will have the parameter, 4% will not. That's the theory that we know. That's what we did in chapter 8.
I think Reagan's saying she said true for me.
Okay. Yes, good. Okay. Let's jump to the next worksheet. This is the 9-4 number 3 worksheet. Let me make sure I'm picking the right one. Good. This is it. Same stuff. I'm going to give you 5 minutes to do number 1. This is where hopefully you're feeling confident and you can do this without any help. So remember, number 1, figure out, is it a proportion or a mean? And then number 2, figure out what they're asking you, which usually means find the formula. So let's do 5 minutes. This is page 670. We've completed the worksheet for 033 for Sunday. This is now the worksheet for 133. And we'll do like 1 or 2 of these, and then we're going to jump to the review itself. So the timer for 5 minutes.
Would I put 2.7 as the bottom as E? For A.
Where do you get 2.7 from?
I'm getting 0.025 out of that 2.5.
I'm on
Good.
the wrong page.
Well, that'll do it. So you were probably right. Now, and then if you heard Laura, because it's a percent, you got to convert it to a decimal. That's the one thing that will catch, that I've seen students get caught on with the proportions. This E in the denominator is always given to you. It's often given to you in percent form. You got to convert it to decimal form. Otherwise, you'll get ridiculously small sample sizes. How we doing? Anyone got an answer?
I'm ready. I got 1,083 people after I rounded up.
Okay,
So did I. I'm still working on B.
excellent. Okay, let's do 3 more minutes for B. 1,083 for A. That sounds right to me. Make sure what you have listed is this formula, your Z critical value, which is 1.965, and your negative point or positive 0.025. What do you think? You got it? Oh, hey, what time?
I think I got it. My kids are arguing. Sorry.
Okay. You're good. What number we got on that, y'all? Should be a smaller number than the 1083.
I got 179.
That seems a little low,
Oh man. That
but I
did it
could be
wrong.
wrong.
So mine wasn't smaller, so I did it wrong then.
1062. Okay, let me type in the number because I don't know it off the top of my head.
That's what I got, Reagan.
That does sound a little bit closer. Yes, I get the same thing, 1062. So Taylor, did you see what maybe went wrong for your 179 and Laura for your larger number? Did you both use 43.43 and 0.57 for your P hat and Q hat?
I use 0.043 times 0.957.
957. So let's see. Okay, so there's the problem. You need to note that your prior estimate is this 0.43. Do you see do you get how we're getting, so to get this into a decimal, we're dividing it by 100, which move the decimal 2 places. We do the same thing here. We're dividing by 100. And so the decimal's there, that moves it 2 places to the left. That's probably where your mistake was. Am I right? I could be wrong. Am I wrong?
Where is the 0.57 coming from?
Great question. What is Q hat? How do we calculate it?
1 minus P, so 1 minus 4.43.
Good.
Damn it, that's where I messed up.
No worries. That's what this is about. We're figuring out where those little hiccups are going to come from, and we found it, and now you don't ever have to do it again. Or you can do it once or twice more, but just not on the exam. Cool. Okay. Excellent. Let's see, 1210. Let's do let's do one more. How about we do 5 minutes on number 3 on page 671? It's just it's parts A, B, and C, and then I'll leave the other little questions for you to read and think about. Number 2 and 4 and 5, and on Wednesday, we can check them if I'm here. Well, I still am not quite sure.
Eric, why don't you just let me? I'll talk to you about it tonight.
Okay. I'm not sure. I could probably zoom in and just be I could be the you.
We'll talk about it.
Okay, let's talk about it.
Yep.
That sounds good. Okay, so let me do 5 minutes on the clock. You all do number 3, A, B, and C, and then we're gonna go to the review. Set a timer for 5 minutes. Siri, timer 5 minutes. Thanks. I don't think we're getting rid of MSL, my stat lab, Taylor. We are kind of talking to each of you all individually about where you're at, and what's happening for you. Sindri, feel free to correct me if I'm wrong on that, but yeah. Mostly what we were doing was taking the temperature of how you all were feeling stress wise with things.
Yeah, I would think. Yeah. So yeah, if you guys have concerns about it, just come to us individually, but I noticed that most of you are right on track where you need to be. You might be a few behind, but you guys are doing fine with it. You too, Emily. We'll see you tomorrow.
Okay. Did you all get letter A?
Yeah, I'm ready for A. I got 7 students.
Seems a little low. Let me make a guess. Did you change 1.2 to 0.012?
No, and I was thinking about it, but I thought that we only did that for percents.
Good. Okay, then that's not a problem. Let's see. So did we correctly identify that this is a mean?
Yeah.
So I'll write this one out. We're going to want to use the 2.8, which is the sample standard deviation. Ooh, 99% confidence interval I don't have memorized. That one isn't as common. Oh, but we did use it earlier. 0.5.
I got 36.1 blah blah blah, so 37.
Okay, that sounds more like it.
That's what I got, Laura.
Nice, Laura. Remember that to have a normal distribution for means, condition 3 says our sample size has to at least be 30. So if you're getting numbers less than 30, that could be a clue that something might not be quite right. Although the fact that we know that the number of vacation days is normally distributed means we could get numbers less. So just a clue. Let's see, Reagan, if we can figure out where you went wrong. Do you see it already or no?
Yeah, I also keep forgetting to square it. Like, I don't know why that last step never happens for
That'll
me.
do it.
So.
That'll do it.
How did you know it was it was a mean?
Great question. It didn't say it anywhere, did it? So it did, but it didn't. This is a more general word. It's kind of like point estimate for the word mean. Researchers wants to estimate the average amount of vacation days. Remember, was it 3.1 when we talked about measures of central tendency way back in chapter 3? Oh, Reagan, no, we do not change it at all. I was just thinking that maybe you had done that. Actually, if you had done that, you would have gotten a much larger sample size. So I was totally wrong, way off base. Taylor, does that help noting the word average?
Yeah. Thank you.
Okay, you're welcome. The other clue is if we give you a standard deviation, we're going to be working with a mean. And then there's another clue that if our margin of error is not a percentage, then you're working with a mean. Proportions have margins of errors in percentages. So those are other indications that we're looking at a mean. Okay, good. So I want to leave the rest of these for your practice. Note, this is another example we needed to round up. What is this? This is 37 college students. Good, good, good. So I want to skip down now to the chapter 9 review. It's on page 672. But before we do that, I want to give you just a brief overview of the types of questions that you encounter in chapter 9. There's really just two. So what I'm thinking here is like the general look of what to do when you approach a problem from chapters really 8 through 11. So the first thing I want you to think about is, what is the parameter? Always and forever. How do we know? What are the clues for which? And there are two types of parameters. There's the mean. And the mean is mu. And there is the proportion. And that is p. The statistic part for this is x bar, and this is p hat. What's going to come with means is standard deviations, data sets, etc. Okay, so once you've determined whether it's a mean or a proportion, number 2 is to ask yourself, what is the question? And for right now, there are only 2 types of questions you have to face. Actually, nope, let me back that up. There are 3 types of questions. You could have the verify the conditions question. And I'm just going to put ... on this because you could verify to see if we can use the central limit theorem, or you could be verifying to see that the central limit theorem allows you to construct a confidence interval. It's like those 2 things. So either you're just going to state the results of the central limit theorem, meaning describing the distribution of the statistic, or you're going to state, because these conditions are met, I can now construct a confidence interval. So verify the conditions. Number 2, it could be construct the interval. And I'm just going to label it CI. Construct the confidence interval. That means find all the pieces, excuse me, find all the bits of information we need, smash it into StatCrunch, and it spits out the lower limit and the upper limit, right? Or the third question is the one we just did in 9.4. It could be the how many question. ... or the estimate the minimum. Remember, these questions, which place you go is based on whether it's a mean or a proportion. So my thought is, figure out the parameter first, figure out what you're being asked, and then from there, find the related information. I would just say here, reference material. Okay, so do we need to know the sample size formula? Is that what we're using here? We would be if we're doing the how many. Do we need the confidence interval information stuff? If that's what you're being asked to do, it'd be there. If it's the verified the conditions, we might be looking at the chapter 8 material to see the 3 conditions. They're in both places. And then the last part here for me is, answer the question, answer it. So identify the pieces in the problem, substitute everything in, get the result. So let's apply that to the questions here. So this is the big chapter 9 review. Number 1 is an example of chapter 7 stuff. It's just find the critical values. So let's come back to that. I think you all are pretty good at this, although you might have forgotten how to do it out of context. Because that's what this is. It's just out of context. It's like, just find this. Whereas with the stuff we just did, you found these things in the context of calculate the minimum sample size. So let's start with number 2. I'm going to give you 3 minutes to do this one, because we did this a bunch of times in the worksheets in 9.1 and 9.2. But follow that strategy as my suggestion. You don't have to. Figure out what it is you're having to do, figure out what question you're having to answer, and then find the information to answer it. So let's do 4 minutes for question 2. So timer 4 minutes. Okay. Tell me first, mean or proportion?
Mean,
Mean.
How'd you all know?
average,
Wait, which question are y'all doing? Number 2 or number 3?
3. That's what she told us to do.
Is that what I said? Okay, I thought I'd said number 2.
No, you
Good.
said number 2.
Well, number 3 is a mean, number 2 is not a mean. So, did you all do number 3? Should we talk about number 3 or do we need to come back? Number
I
2.
did it.
I did number 2.
Okay, Laura, tell us what you did with number 2.
Please.
I did the 0.24, and then I did the, in parentheses, 0.306 divided by 1.9 squared.
So, okay, so I love that you said this is proportion. Excellent, proportion. What's the question you're being asked to do in number 2?
So I used the mean one instead of the proportion one. So I did it wrong.
Good, good. Okay, perfect. But what's the question? Let's figure that out. What are you being asked to do in number 2?
What is the confidence interval?
Okay, so let's pause and ask ourselves, what would that answer look like? Actually, maybe let's go back to 3 minutes on this one. Now that we kind of know what it is. Those of you that didn't do number 2, do it. If you didn't do it, yeah. And then Lori, that'll give you a chance to think through how to fix it. Be careful. You might not need a reference sheet for number 2.
isn't
Okay.
it just 24%?
What does a confidence interval look like? Like, what's the
It's
answer?
in parentheses. It's like the lower limit and the upper limit.
Okay, so the 24% has something to do with that. In fact, let's pause and ask ourselves, where is the p hat in every single confidence interval? And I could change it and say, where is the point estimate? Generally speaking, where is that point estimate in every single confidence interval?
The center.
The center. Okay, so this 0.24 is actually the center of whatever this confidence interval is. Where is the margin of error?
It's 1.9, so we do 0.24 minus 1.9 and plus 1.9 to get the upper and the lower.
Be careful because you mixed percent and decimal there. So if you're going to use 1.9, that's 1.9%, add it to the 24%, or convert them both to decimal.
0.019. Okay. Yikes.
Right, all those little tiny pieces to keep track of. Okay, so the upper limit is 0.259. That's 24% plus 1.9%, which is 25.9%. The lower limit is the subtraction of those two, which is 0.221 or 22.1%. How's everyone feeling about that?
So you guys, if you look at your flow chart we did on page 223, it's one of the things that we have, like the bullets to remember. If you pull down, it's the basic formula, confidence intervals, always file. It's the third one down, Eric. Basic formula, and that we filled that in is that it was the point estimate plus or minus the error. And this is the one that you always want to do more complicated. We always want to try to do more than what it really is.
Yes, I often see on final exams students trying to type this into StatCrunch. to find that confidence interval. And you can't because you don't know the sample size. If we knew the sample size, then you could. Because we could multiply the sample size by 0.24, which would get us X, and all we need is X, the sample size, and the confidence level. The problem is we don't know the confidence level either. So you're really stuck. The only way to do this is to remember that the basic properties of a confidence interval. It's the point estimate plus or minus the margin of error. I think students across sections of stats must have missed this problem a lot, because these new worksheets, we've done this one like 4 or 5 times, I think. And I remember in the past, there weren't that many practice problems of this. Okay, good. We've established that number 3 is a mean. Have we established what question we're being asked?
How many?
Good. So which formula are you using?
The n equals the sample size for the mean one on the second page.
Nailed it. This one.
Yeah.
Okay. Love it. I think you all can do that because we just did 2 of those. You've got everything you need. Your Z critical value. Oh, it's one we've already used too. 1.965. No, 1.645. Phew. Okay, I'm going to move on from this one unless someone is like, no, I don't know how to do it.
Yeah, I'm good to move on.
All right, let's move on. Okay, so I'm gonna set the time. I'm gonna pause myself for 5 minutes because I have a hard time pausing, and I'm gonna let you do number 4. See how far you can get. The goal is to get through C. It's not a rush. It's not a race. So if any of you are feeling pressure about speed, don't feel it. I'm just noting the clock. We have 23 minutes left, and I kind of want to at least talk about each one of these to get you started. So 5 minutes, and we'll check in. Set a timer for 5 minutes. Okay, how do we do?
I'm ready to go over it.
Awesome. What is this? Mean or proportion?
Proportion with no prior.
Okay, A we know is proportion because it says estimate P. And yes, Reagan, love it. It says no prior. So let me, I haven't been doing this. Let me highlight the pieces we need. We need the sea level. We need the margin of error. And that's it for this one. What answer did you all get?
For the first one, I got 1,354.
So Taylor so what would you have to do to that?
Round it to 55.
Yes.
Nailed it. Excellent. Good. So if you left it as 1354, you would lose like a point or a half point because you just forgot to round up. Good. Okay. Excellent. So B, what is that? I forgot to say what question are being asked to do, and you all just nailed it. Estimate how many. All right. So B, how does that change things?
It has a prior estimate because it was in June 2020.
That's it. We stated a date. We said, hey, we thought the proportion was this. Okay, so that just changes what we multiply by, changes the formula. So instead of just using 0.25, which by the way is a 50-50, that's 0.5 times 0.5. So we're just saying, oh, 50% of the population is going to go either way. Since we don't know, that's going to be our best guess. That's where the 0.25 comes from. But then when we know it's something different, this number becomes a little bit smaller. So 0.8, 0.82. Did you all get 800?
Yes, I did.
Excellent. Excellent. Okay, anyone lost, confused, stuck? I only gave you 5 minutes to work both of those problems, which may not have been enough time.
I keep forgetting the damn Q.
Ah,
That's why my answers are so off, and I did it again.
now, so I'm being kind of like, is the word lazy, right? I'm not writing down the formulas. Are you writing them down, Laura?
Yes, I'm writing it down, and I still managed to forget the Q.
Okay. Well, good. At least you're consistent about, and you're beginning to internalize which mistake you're making.
Right.
I'm doing my best to be positive here. Yeah, that's okay. You're gonna get it. Good. Okay. So let's look. I think so. We've got here's what we've got left. We've got some basic. This is the same question as number 2. Essentially, it's just now maybe with a different parameter. These are some like, hey, Laura, remember to find Q. Here's how you do it. And here's a like, do you remember how to find X? And then here's 2 more big problems, which are the most similar to what's going to be on the final exam. It's the prompt and then these 4 parts. In terms of, so let's do 5 minutes on 8 and let's see how far you get. Set a timer 5 minutes. I'm saying go to page 674 and try that for 5 minutes. Okay. That was 5 minutes and we're quickly running out of time. Anyone identify what parameter this is dealing with?
Prior, because it said 2019.
Prior. Okay, but prior isn't a parameter. That's certainly a suggestion that
Oh,
we would use like one of these two problems, right? So it's not, that's not terrible thinking. It's good to note that, although it's not helpful in this case, unfortunately. So really, I'm saying, are we working with a mean or a proportion?
Proportion.
How do we know?
I just knew from looking back on the notes for a single population proportion.
But what was it that told you? What in the notes did you see that said this is the same problem as a proportion problem? You're right.
Is it a survey?
That's helpful. What else? Did anyone look at A and look at this thing right before the end of the sentence? Verify the requirement.
4P.
4P. That's like the clearest, like you're doing proportion. Now, survey is a good suggestion. Most often the surveys we do are like yes or no questions. We got a sample size. That's common for means though, or you're going to have a sample size with a mean. The other super huge clue is this percentage. Means are not percentages. Cool. Okay, what's the question for A?
Random, independent, normal.
Love it, Taylor. That's it. You're doing the random, independent, and normal for a proportion. So if I scroll up to that here, we're doing this thing. Random, it's given, n is less than or equal to this, and then n times p hat times q hat. Okay, cool. What is the question in B?
The formula, substitution and results for the single population proportion formula.
Which formula? You doing a sample size? You constructing a confidence interval? So is it one of these formulas? Go ahead. Which one is it?
I'm on page 211, the right formula.
The right formula. What is right?
The one on the right.
Oh, gotcha. 211. The one on the right. This one.
Yeah.
Love it. Okay. In other words, you're constructing a confidence interval. Good. How did we know we were supposed to construct a confidence interval in that question?
It says it.
Okay. I don't want anyone to think, isn't that obvious? Because I can't tell you how many times I've graded a problem where it says verify the requirements for constructing a confidence interval for P is stated, and I get a confidence interval in this answer. So I'm just like, I want you need to read these so carefully because you all know what to do. You just got to make sure you're checking, you're following what you're being asked to do. Good. So in the end, you're going to have this lower limit, upper limit thing. You're going to have that formula written down, blah, blah, blah. Do you all remember how to interpret the interval? It's been a couple minutes since we've done that. Can anyone start the sentence?
It starts with, I think we are 90% confident that, and then I don't know the rest.
We are 95% confident. Excellent. And then you're going to say that the true, and you're going to insert the word parameter, the true population parameter. In this case, that parameter is proportion. So the true proportion of US adults who say medical doctors care about the best interests of their patients all or most of the time is within this number and this number. Okay. Do you remember these? Because this is what we did last week on Monday. Actually, we did proportions on Wednesday of the 2 weeks ago. So it's been a while since we exclusively did this particular problem. This problem we did on Monday of last week. Note you're working with a mean because it says mu here. Note this says verify, not construct, verify, and then it says construct, and then interpret, and then test a claim. All right, so you've got 3 minutes to do this. Just kidding. I'm gonna set you loose. You're gonna work on these, and at some point we can check your answers. And I want you to try to get these. I know, like Taylor, you're saying in the chat that these are the things that help you the most. So focus on these, do this first, see if you can't get this. And then as you're working through StatCrunch, what I would encourage you to do is maybe have these worksheets in front of you and try to see how they are the same questions, even though the words are a little different. I think there's great value in having someone ask you the same question from a different angle. It helps you understand it deeper. But if you're limited on time, get this done first. Okay, so what questions do you have in the last 2 minutes of class here?
So we're gonna like kind of finish this up by ourselves. You want us to do the rest of the 9 review?
Yeah.
And
Do
then
the
we'll check
whole chapter
over.
9 review.
Okay, got it. And we'll check over it on Wednesday.
Yeah, or
Okay.
during tutoring hours or Monday of the following week.
Got it.
And we have essentially done we've done most of the questions because you all did number 1 and we talked through the answer, and number 3. Some of these smaller ones I left for you to do. And then there was one other, this was the 9-4. You had a few questions to finish on that, and then a couple questions on the review. Okay. If there's no further questions, enjoy your families that are with you because of hackers, I guess, shutting things down. I don't know if you're doing the same thing as me, getting 1,000 emails that say, hey, you haven't paid for this, or here's a job, you can make $700 a week, or click this link, blah, blah, blah. Don't do it. That's probably why the county is shut down, because someone clicked that and let them in. Just report those as phishing and move on, or delete them. All right, we'll see you all Wednesday.